I'd like to do a quick little example of blue, but first, here's a property that you may find interesting. Remember that we found that the expected value of x naught minus x naught hat squared could be was a quantity that we were trying to minimize when we found our blue, our best linear unbiased estimator, and we simplified that to be just equal to the trace of L naught R L naught transposed. So that gives us what our error is. Let's evaluate that. What is that? We'll call it the blue error. Well, that's equal to the trace of, actually, I'm skipping a step. So L naught R L naught transpose is equal to A transpose R inverse A all inverse. We did most of the steps for arriving at that up above. And now, so this quantity evaluates to the trace of A transpose R inverse A inverse quantity inverse, which is equal to the sum of the eigenvalues of A transpose R inverse A all inverse. And that's sometimes called the information matrix. Okay. On to our example. Let's do this. So let's assume we have y is equal to a x naught plus e, where a is just equal to 1, 1. Y is equal to 0, 5, and r is equal to 3, minus 1, minus 1, 2. So the first thing we need to do is find our inverse, and we get 1 over 3 times 2, 6 minus negative 1 times negative 1, so that's just 1/5. Then we negate the off diagonals and swap the diagonals for a 2 by 2, and there we are. Then x hat blue is equal to 1, 1, that's A transpose, times R inverse, 2, 1, 1, 3, times A. We've got this 1/5 that shows up out there. All inverse times A transpose, which would be 1, 1. R inverse 2, 1, 1, 3 times 1/5. times y. 0.5. Okay, so that 1/5 and that 1/5 cancel because of the matrix inverse there. That pulls out. So now we have I'll do it in steps. 3/4 times 1/1 inverse. 3/4 times 0.5. So that's 1/7 times 20, and that's it. So 27ths. So x hat blue is equal to 20/7. Okay. Next, let's see if we can't figure out what the actual error is. And where would we go to get that? Well, there we go. Well, we just solved this, right? It's the sum of the eigenvalues of A transpose R inverse A quantity inverse. But that's just one expression for it. And I think it is not the easiest one to use, although actually it may be. So this quantity up above, right there, is our A transpose inverse. Almost. We had this factor of 1/5 we had to deal with. So let's just recalculate this just to make sure we do this correctly. So that's going to be equal to the trace of A transpose R inverse A -1. And so that will just be the trace of 1/1 times 1/5 times 2/113 times 1/1 inverse. So this inside quantity can be simplified rather quickly. Once again, we have a 3 and a 4, so we're going to have 1/5, and then we have 3/4 times 1/1 is going to be 7. We want to invert that, and it's the trace of a scalar. Life is easy. So 7/5, that's going to be equal to 5/7. And that's it. That's our error.